Alright, this is chapter 12, lesson 6, and today we're looking at mechanical modelling with vectors. This is not too bad, but you need to be pretty decent with your mechanics, as well as obviously be pretty decent with 3D vectors. But this is the last lesson of chapter 12, which is also the last lesson of the Year 2 book. So let's get cracking with it. We've got a particle with a mass of 2 kilos, so we're going to be using it, that is m equals 2. It's acted on by 3 forces. Really, these should have subscripts. They should have F true, F sub 1, F sub 2, and F sub 3, but I couldn't figure out how to do it on my computer. So we've got these 3 forces here. Give the resultant force acting on the particle. Now, what you can imagine is that there's some particle being pulled and pulled and pulled in a particular way. Okay, and you should know from mechanics that to get a resultant force, you can just add these bits up. So to get that, R is going to equal, use column vectors because it's easier, so you've got 2i plus 3i plus 3i. You've got 3j plus 4j, take away 2j, and you've got 0k plus 5k minus 2k. Okay, and so R, the resultant force acting on the particle, is going to be 2 plus 3 plus 3, which is 8, 3 plus 4, which is 7, take away 2, which is going to be 5, and you've got 5 take away 2, which is 3. And so that's R. It could also be written as AI plus 5J. This should have N because it's a force. So we can go with 8I plus 5J plus 3K. Okay, now finding the acceleration of the particle, this is part B, relies on you being able to use this F equals ma formula. Okay, so for part B, you've got the resultant force, which is this stuff. Okay, so we've got 8I plus 5J plus 3K is equal to mass, which is 2, multiplied by the acceleration, which is A. And so therefore, A, in this case the acceleration of the particle, will equal, we're going to divide through by 2, so we'll have 4I plus 5 over 2j plus 3 over 2k meters per second squared. Okay, next it says give the magnitude of the acceleration. Now to give the magnitude of the acceleration, it means that we're going to be finding the magnitude of this thing here, which is going to be the square root of, we're going to have 4 squared plus 2.5 squared plus 1.5 squared. It's just a little bit easier for me to write them as decimals because I might run out of space. So let's have a little look what that comes out as. So we've got 16 plus 2.5 squared plus 1.5 squared equals, and we're going to root that answer and we'll get 7 root 2 over 2. Okay, 7 root 2 over 2 out of our calculator. Okay, now the next question, it says given that the particle starts at rest, so when t equals 0, okay, the velocity is also equal to 0, so when t equals 0, u equals 0, give the distance travelled by the particle in the first 5 seconds. So we've got the distance travelled is going to be the displacement. Okay, we know the acceleration and we know the time. Okay, we're going to be trying to find this out. We know this, we know this, we also know this. So this is the one we want to find. So we want to find a formula that's got u, a and t all on the right hand side with s on the left. Okay, which happens to be this one here that we're interested in. Okay, so we've got s is going to equal ut plus 1/2 of at squared, where u, which is the initial velocity, is equal to 0, t is going to equal 5 because there are 5 seconds being used, and a is going to equal 7 root 2 over 2. So s, the displacement, is going to be 0 times 5 plus 1/2 lots of 7 root 2 over 2 lots of 5 squared. Now that is going to equal s equals, so we're going to get 0.5 multiplied by, open brackets, we've got 7 root 2 over 2, close the brackets, and then we've got 5 squared. That should all go into your calculator absolutely fine. So you get 12.5 multiplied by 7 root 2, and then divide that by 2. Okay, and we should get 61.87. 61.87. Of course, you could give that more precisely. You could use your calculator to get this a little bit better. Okay, which is 25 times by 7. 25 times by 7, 175 root 2 over 4. Okay, which equals that. All right. So that's the distance. It should be absolutely fine to figure that one out. Now the tasks for you is exercise 12D. The questions on there are all of them. It's not too bad, provided you're pretty decent with your mechanics. The extension is in the mixed exercise. It's page 351, question 12. It's just that that's a little bit more difficult than what's in the actual questions for this exercise. And that's it for 3D vectors. It's done. Okay, nice and quick. And for some of you, it will be the last thing that you have to do. All right, cheers.